Welcome back to Griffonomics, where we conduct financial investigations to define the risk before we look at the reward.
And today, we are really diving into something massive.
Absolutely. Today we're diving into the AI chip war. We're going to dissect this huge infrastructure battle that's, completely reshaping the technology sector.
It really is.
And our mission, which many of you have asked for, is to synthesize this just enormous stack of articles and data, the revenue reports, the competitive announcements, all the structural risks, and forge it all into a clear, actionable investment thesis.
And that clarity is, it's non-negotiable. Because what we're looking at here isn't just another tech cycle. We're really analyzing the battle for what Oracle's CEO, Larry Ellison, has called the largest, fastest-growing business in human history.
That's a huge statement.
It is, but the growth rates are just unprecedented. And the stakes for Nvidia, for the hyperscalers, for, the entire global economy, it's really about the profit margins of the next decade.
And with that kind of scale, you need a really focused lens. So we've tried to cut through the noise, and here's the core two-sentence thesis we've pulled from all the data.
Okay.
The AI sector is defined by the battle between Nvidia's undisputed hardware hegemony, which is currently protected by this defensive moat of its proprietary CUDA software, and the aggressive pivot by massive hyperscalers like Google and Amazon to deploy cost-efficient custom ASICs, things like TPUs and Trainium, all driven by this monumental shift to inference monetization.
And what that really means, when you boil it down, is we're analyzing two different time horizons and two different battlefields.
Okay, explain that.
We're checking who controls the short-term, high-margin, high-cost training market. That's where the foundation models get built, and it's clearly Nvidia today.
Right.
Versus who controls the long-term, high-volume, cost-sensitive inference market. That's where those models get used and crucially monetized. And that is exactly where the hyperscalers are making their really aggressive margin-attacking move.
So it's a fight between raw performance and long-term efficiency.
That's it in a nutshell.
Okay, so let's start with the incumbent fortress. Nvidia, their hardware hegemony, and what you call the high wall of the CUDA software moat.
It is genuinely difficult to find a precedent for the kind of market dominance Nvidia has right now. I mean, they are the unequivocal market leader in high-performance computing.
They seem to be miles ahead.
They confidently claim to be a generation ahead of the industry, and that's in terms of broad applicability and performance. They didn't just create a product, they created the standard for what AI computing has to look like.
So their chips, their GPUs, they're kind of the Swiss Army knife of this whole world.
Exactly. Their fundamental claim is that they are the only platform that reliably and efficiently runs basically every AI model everywhere that computing is done.
And the financial statements. I mean, they don't just validate that dominance, they show an acceleration that's, it's almost hard to compare to other mega cap tech companies in history.
Oh, absolutely. If you just look at their AI engine, the data center segment, the numbers are simply colossal.
What are we talking about?
Data center revenue hit a staggering $51.2 billion in Q3.
$51.2 billion.
In one quarter. And that figure is mind-bending on its own, but the growth acceleration is where the real story is.
Right, the rate of change.
That $51.2 billion is up 66% year over year and 25% quarter over quarter.
66% year over year. To put that in context, I mean, when Apple was at a similar market cap, hadn't seen growth rates like that in over a decade, right?
Not even close. This isn't just growth. It's exponential compounding on an already immense base. And that's why the market fears of some immediate bubble bursting are, a bit muted, at least for the short term. The demand just shows no signs of saturation yet.
But the scale of that success, that accelerating growth, that's precisely what's attracting all this competition we're about to get into. The source material highlights that Nvidia's gross margins are, and I'm quoting, persistently massive.
Persistently massive is right. They are consistently hovering around the mid-70s.
75% gross margins. When you're selling a product at that scale and keeping 75 cents of every dollar as gross profit, you are essentially painting a giant neon target on your back.
It is. As one analyst put it, that margin is the giant kick-me sign that attracts every competitor on the planet. It's daring them to try and undercut your pricing.
You have to know that, though. They know the target is on their back.
Of course. But what gives Nvidia the confidence to keep that aggressive pricing isn't just their current hardware. It's their incredible financial visibility into the future, their locked-in sales pipeline.
And that visibility is a key anchor against any fears of a downturn. The company has secured, what, $500 billion?
Yeah, $500 billion in bookings for its next-generation Blackwell and Rubin AI chips. And those orders aren't for next quarter. They run straight through the end of 2026.
$500 billion in secured forward revenue. That is almost unheard of in any industry, let alone the, notoriously fast-moving semiconductor market.
It essentially locks in their position, their data center revenue, for the next 2 years. And what's even more crucial, and their CFO clarified this, is that this massive $500 billion figure does not include the ongoing work and future commitments they have with OpenAI.
So the number is likely conservative.
It's likely very conservative in terms of their total forward pipeline, and this gives them immense stability to just keep investing and extending their technical lead.
So that massive financial runway gives them stability, but the real structural defense, the high wall that competitors are constantly complaining about and struggling to get over, is their proprietary software platform, CUDA.
That's the invisible lock on the door.
It's their secret weapon.
It really is. CUDA is NVIDIA's true secret weapon. It's the operating system, it's the glue, it's the entire developer ecosystem all rolled into one. It is a proprietary platform that acts as a high wall protecting their market share. Because, to put it simply, every serious AI researcher, every grad program, and every seasoned developer, they've all been trained on and are locked into using CUDA.
Okay, so let's unpack the real cost of that lock-in for a customer.
Yeah.
Let's say Google or Amazon releases a chip that's, 30% faster, 50% cheaper.
Right.
But it requires the customer to completely re-optimize or, rewrite billions of lines of code using a whole new software framework. That marginal cost saving just vanishes, right? It's swallowed by development expense and deployment risk.
Exactly. The human capital cost is astronomical. It's not just about the hardware you're buying, it's about the mind share they've captured. Competitors like AMD, which offer an open source alternative called ROCm, or even the hyperscalers with their own custom silicon, they still struggle to displace Nvidia because of this deep ingrained software dependency.
So Nvidia can confidently say their chips offer greater, what was the phrase? Performance, versatility, and fungibility.
That's their pitch. The GPU is the highly flexible, constantly adapting general-purpose workhorse. You can use it for training, for inference, for graphics, for simulation. It just does it all really, really well.
And if you're an AI lab spending billions on foundational research, that versatility is a feature you're willing to pay a 75% gross margin premium for. You're hedging against future use cases, which is more valuable than optimizing for just one task today.
Precisely. Which brings us squarely to the counterattack. The forces that are trying to breach that CUDA high wall, the hyperscalers and their custom ASICs.
This is where the core investment conflicts really starts to take shape.
It is. The hyperscalers, we're talking Google, Amazon, and others, are aggressively investing in and building their own custom ASICs.
And an ASIC, an application-specific integrated circuit, that's a different kind of chip entirely, right?
A completely different breed. They're engineered to be specialized tools, not generalists. So if NVIDIA's GPU is that Swiss Army knife we talked about, the ASIC is like a bullet train. It's incredibly fast and efficient, but for one specific task.
But in this case, that one task is the high-efficiency, lower-cost math you need for the high-volume inference phase of AI.
Exactly.
And the undisputed pioneer in this space is Google, with their tensor processing units, or TPUs.
Right. And this wasn't some sudden competitive move. They built them out of sheer necessity, really. Starting way back in 2015, the sources say that NVIDIA's hardware was just too expensive and difficult to acquire in the large quantities Google required to run its own services.
Just for things like search and their internal AI.
Right. Their initial motivation was independence and securing their own supply chain. And TPUs are just specialized ASICs engineered for the dense matrix math that's at the heart of deep learning.
And we have the ultimate validation point for how good their tech is, don't we?
We do. Google's superior generative AI model, Gemini 3, which has been widely reported to have surpassed rivals like ChatGPT in key industry benchmarks, well, it was trained entirely on Google's own TPUs.
That's a huge proof point.
Right.
It shows the TPUs are effective not just for cheap inference, but for the most demanding large-scale training tasks.
It absolutely does, but that's just the technological validation. The strategic move that really escalated this into a full-blown chip war, the one that sent shockwaves through the market, was the report that Google plans to sell these custom chips directly to other companies.
So they're shifting from just being a cloud renter of their own tech to becoming a direct hardware provider.
And that is a game changer for the entire competitive landscape. Google is reportedly in talks to sell billions of dollars worth of TPUs directly to Meta platforms.
To Meta.
To Meta. And these sales could potentially begin as early as 2027. This moves Google from just being an internal cost center to an external margin-attacking competitor to Nvidia.
And crucially, Meta isn't just looking at them for cheap inference.
Yeah.
They're reportedly considering using TPUs for training their next-gen large language models.
That's the real threat. That is the most compute-intensive, high-margin task that Nvidia currently dominates.
So what's the market impact of a deal like that?
It's immediate and it's quantifiable. This potential Meta deal is estimated to capture market share equivalent to about 10% of Nvidia's annual revenue.
10% from one deal.
From one negotiation. It signaled a clear and present danger to Nvidia's premium pricing power. It shows there is a viable, high-performance, cost-effective alternative out there, one that was built and validated by one of the world's most sophisticated AI labs. This is the first really sustained threat to that CUDA moat.
Okay, so while Google is attacking market share with its model-validated TPUs, let's turn to Amazon Web Services, AWS. They're attacking margins and the whole operational deployment model with their Trainium chips.
Right. AWS is competing fiercely on cost sensitivity and efficiency. They launched their Trainium 3 chips, developed internally by their Annapurna Labs custom chip design unit.
And the main selling point here is cost, right?
It's all about cost. The primary competitive advantage of Trainium 3 is its ability to cut the cost of training and using AI models by up to 50% compared to equivalent GPU-based systems.
50%. That's a direct, undeniable attack on NVIDIA's pricing premium.
When you think about a large model costing a company hundreds of millions, maybe even billions, a year to run, a 50% cost saving is just impossible to ignore.
It reinforces that idea that the long-term winner here will be whoever provides the cheapest, most efficient compute, especially as we move into that high-volume inference phase.
And what's particularly sophisticated about Amazon's strategy is that they aren't necessarily aiming for a total replacement of Nvidia. They're pursuing a path of co-opetition.
Co-opetition, so competing and cooperating at the same time.
Exactly. They want to diversify their own supply chain and offer alternatives to customers, but they're also preparing for a world where Nvidia remains the technical gold standard. And the proof of this is the announcement that their next chip, Trainium 4, will actually support Nvidia NVLink Fusion high-speed chip interconnect technology.
Okay, let's unpack that because that's a critical technical detail. What is NVLink Fusion, and why on earth would Amazon adopt NVIDIA's proprietary standard?
So, think of this chip war as a logistics challenge. To train these huge models, you don't need one chip. You need tens of thousands working together seamlessly. NVLink Fusion is NVIDIA's proprietary high-speed highway that connects all those chips in a data center. It's what lets them talk to each other faster than anyone else.
By supporting it.
By supporting it, Amazon is building a hybrid modular infrastructure where they can seamlessly integrate their 50% cheaper Trainium ASICs right alongside NVIDIA's powerful GPUs. They can leverage the best of both worlds. It creates flexibility, and, it lowers the switching costs for customers who already use NVIDIA's networking.
That is a profoundly intelligent strategy. You're using the incumbent's best tech to make your own rival chip more accessible. And AWS is also disrupting the deployment model with something they're calling AI factories.
Right, and this seems designed to capture the most regulated and security-conscious customers out there. It's a move toward a white-glove service for the enterprise.
So what is an AI factory?
It involves deploying dedicated AWS AI infrastructure, which includes both Trainium and NVIDIA chips, directly into a customer's own existing data centers. It's not just a cloud rental. It's an integrated, managed private cloud solution.
So it addresses that fundamental fear that big companies have about losing control of their data when they send it out to a public cloud.
Correct. It's specifically designed to address huge concerns like data sovereignty and regulatory requirements. It allows massive regulated organizations, banks, pharma companies, government agencies, to use the latest chips and AWS resources while keeping their data physically on their own premises.
That would make AWS extremely sticky for those kinds of institutional customers.
And we know it's working. We have immediate market adoption. Anthropic, a major rival to OpenAI, is a massive customer. They're already using more than 1 million Trainium 2 chips to build and deploy their Claude model.
So the adoption by a hyperscale model developer proves these custom alternatives are serious validated competitors.
And that diversification by Anthropic, who uses Amazon's Trainium, Google's TPUs, and Nvidia's GPUs, is the clearest signal of the future. It's a compulsory multi-cloud, multi-chip strategy. Companies are actively spreading their chip use to lower risk and keep price pressure on all their suppliers.
And this whole focus on price performance and efficiency leads us right to the biggest market shift happening now, the inference supercycle. If the chip war is about cost, this monetization cycle is all about volume.
This distinction is everything. We need to be really clear on this. Training is the massive R&D phase. It's the billion-dollar, compute-heavy, slow process of feeding a model data until it learns. It uses high-margin chips like Nvidia's H100s.
And inference.
Inference is the mass utilization phase. It's when you actually use the model asking ChatGPT a question, translating text, generating code. It's low cost, high volume, and it has to be lightning fast. This is the monetization phase, and it requires maximum efficiency, which is why ASICs are targeting the space so aggressively.
And the numbers that illustrate this monetization wave, look at OpenAI's trajectory. It's entirely reliant on the success of this shift to inference.
OpenAI is riding this wave with explosive growth. Their annualized revenue rose steeply to $13 billion in 2025, and crucially, this was driven almost entirely by inference applications, API calls, ChatGPT usage, not the initial training costs.
And the projections are even crazier.
The company is projecting it will reach a staggering $125 billion in revenue by 2029.
$125 billion. That massive 10x growth isn't just coming from the core ChatGPT product, is it? The analysts are saying it's from new high-value applications.
Exactly. We're talking around $20 billion from APIs, over $25 billion from various new products, and another $25 billion from something called AI agents.
And that transition to agentic AI seems to be the next big frontier.
It is. We're talking about autonomous, scalable programs that can execute complex, multi-step tasks without constant human babysitting. Everyone from OpenAI to AWS is targeting this. AWS is heavily promoting its frontier agents, like the Kiro Autonomous Developer Agent.
So this is the future of automated enterprise services.
It is. And every single time one of those agents makes a decision or executes a step, it requires an inference call. That's the volume, that's the scale that justifies building 50% cheaper chips.
So while the money is flowing in and the projections are soaring, that rapid monetization has apparently created some intense competitive pressure, forcing the market leader, OpenAI, into a very public defensive posture.
The pressure is extremely real. CEO Sam Altman reportedly declared an internal code red. He told employees the company needed to immediately divert resources and focus all its energy on rapidly improving the core ChatGPT product and expanding its audience, which is already at 800 million weekly users.
Which suggests their grip on the market isn't as secure as those revenue projections might imply.
Exactly. And this code red wasn't just some internal streamlining. It was a direct reaction to rivals gaining significant ground.
What were the specific threats that triggered it?
It was twofold and highly impactful. First, on the technology side, the launch of Google Gemini 3, which, as we said, was trained on Google's own TPUs, reportedly surpassed ChatGPT in key industry benchmarks. That's a clear loss of model superiority, at least for a time.
And the second threat?
The second was commercial. Anthropic is showing explosive growth in the critical enterprise space. They went from under 1,000 business customers 2 years ago to over 300,000 business customers by September. That is aggressive enterprise penetration.
That combination of losing model superiority and seeing a rival gain commercial traction is exactly what forced the sacrifice. The code red reportedly forced OpenAI to pull back investments in high-potential areas like shopping, their own AI agents, and a personal assistant product.
They're ceding ground in the crucial high-value agentic AI space just as that sector is starting to explode. And that strategic desperation, fueled by this pressure to maintain market share, leads us directly to the most significant structural risk in the entire AI ecosystem.
The financial fragility of OpenAI's massive infrastructure commitment.
That's the one.
Let's contextualize this, because the numbers here move from corporate spending into, the realm of national GDP. OpenAI has committed to more than $1.4 trillion in infrastructure deals over 8 years.
And that's despite the company itself not yet being profitable.
How does a non-profitable company sustain commitments of that scale?
The question of liquidity and solvency is central, and it highlights the extreme financial interconnectedness of this entire supply chain. This massive infrastructure build-out involves billions tied up in circular investments with its major tech partners: Nvidia, Oracle, AMD, Microsoft.
Okay, can you explain that concept of circular investments? Why does that create a systemic risk rather than just a normal business partnership?
It means the tech giants aren't just selling OpenAI products for cash. They are simultaneously supplying the infrastructure, the chips, the cloud space, and investing heavily in or guaranteeing financing for OpenAI to make sure it stays solvent and keeps buying their services.
So it's like Oracle commits resources to build a cluster for OpenAI.
Which then ensures the sale of 450,000 Nvidia chips, which in turn secures revenue for Nvidia. If OpenAI were to falter, that financial failure would immediately cascade through the revenue pipelines and the balance sheets of its creditors and investors.
The sources drew a heavy analogy here, comparing this interconnectedness to the web of interdependent obligations among global banks before the 2008 financial crisis.
That is the fear. If the monetization supercycle hits some unexpected roadblock, if that inference revenue doesn't grow fast enough, or if the code red fails, that failure wouldn't be isolated to just one company.
It would trigger a cascade.
A cascading complexity involving Nvidia, Oracle, and others, who have billions tied up in these complex debt structures and forward commitments. The risk isn't just a technology failure, it's a systemic financial architecture failure baked right into the supply chain itself.
And the market has already shown nervousness about this. When it was reported that a huge chunk of Oracle's sales backlog was directly tied to OpenAI, Oracle stock took an immediate hit, right?
It did. It rolled over, highlighting this immediate concern that relying too heavily on the financial health of a single non-profitable client creates a profound vulnerability, which is why Oracle's structural position is so fascinating.
How so?
They are both a crucial enabler of OpenAI's growth, and they are building a strategy designed to bypass that volatility by focusing on a totally different competitive moat: enterprise data control.
Okay, so let's transition to Oracle's strategic role. They are really the only major player that combines this immense AI infrastructure capability with scaled enterprise applications. They're vertically integrated in a way Amazon and Google just aren't on the application side.
Exactly. Larry Ellison's vision isn't just about selling cloud space. He sees the AI era as the largest, fastest-growing business in human history, and Oracle is placing a massive, tangible bet on the physical foundation required to make that happen.
And the cornerstone of that commitment is a project of colossal scale, the one in Abilene, Texas. Oracle is building the world's largest AI cluster for OpenAI there.
And when you analyze the sheer scale of the hardware, it's just staggering. When that project is fully provisioned, that one single cluster will house over 450,000 NVIDIA GB200.
450,000. To give you a sense of scale, the GB200 is one of the most powerful and energy-intensive systems ever made.
And this undertaking requires so much more than computer science. It's massive civil engineering. They're building new power lines, extending natural gas pipelines for dedicated turbines, constructing specialized liquid cooling systems, just to manage the thermal load of what Ellison calls this 1.2 billion watt AI brain.
It's a commitment to the physical architecture of the future.
It is. But their true strategic differentiator, the unique moat that secures their long-term value, is their ability to control data access and relevance using something called a RAG.
This is critical. RAG is the bridge that connects the power of massive public models like ChatGPT or Gemini to the proprietary, highly sensitive internal data that corporations have. That's where the real value is.
Precisely. Oracle uses RAG, or Retrieval Augmented Generation, through its AI data platform. Think of RAG as a highly secure librarian. It lets the AI model, the brain, securely connect to all that private, high-value data that already lives in the Oracle database.
So the genius of it is that the huge public models don't have to be retrained on sensitive corporate data, which would risk exposure or leakage. They're just allowed to look up the relevant internal documents in real time.
That is the crucial business benefit. It allows the models to reason and generate insights based on proprietary enterprise data, which is the peak value use case Ellison talks about, while guaranteeing, through the Oracle platform, that the private data remains completely private and secure.
A non-negotiable for regulated industries like healthcare and finance.
Absolutely. Without ARG, these institutions can't safely adopt generative AI beyond, trivial applications.
And Oracle has also engineered this ARG platform to be cloud agnostic, which is another huge strategic advantage.
It's the ultimate insurance policy against the threat from Amazon and Google. The Oracle database can retrieve data not just from its own storage, but remarkably from sources like Amazon Cloud Storage.
So they're aiming to be the indispensable data reasoning layer, regardless of who's providing the underlying cloud.
That's the end game. They're positioning themselves as the company that can actually take the raw compute power and turn it into verifiable, secure enterprise solutions that solve complex logistical and regulatory problems.
Okay, so if we synthesize all of this really dense data for you,
Yeah.
the core conflict remains. It's the high-margin incumbent hegemon versus the cost-attacking long-term ecosystem controllers.
And we come back to that central investment conflict. Can Nvidia possibly maintain its phenomenal, unprecedented mid-70s gross margins and its massive pricing premium indefinitely, just because of the CUDA moat and its generational hardware superiority?
They have the short-term visibility, but can they hold that line long-term against efficiency?
Or, conversely, will the hyperscalers, namely Amazon and Google, win the long-term, high-volume inference race by leveraging their custom ASICs Trainium 3 and TPUs to provide compute that is, as the sources claim, up to 50% cheaper at scale?
And if they succeed, they could commoditize the underlying hardware and just crush Nvidia's margins.
Our conclusion, drawn directly from the strategic pivots of these big tech players, is that the ultimate long-term winners are likely the ones who successfully provide the cheapest and most efficient infrastructure, coupled with the application control needed to secure enterprise data. The monumental wave of inference and agentic applications is driven by volume, and volume always, always favors efficiency and low cost.
So the cost cutters, the hyperscalers, are inherently attacking the core profitability of the premium hardware providers.
That's the battle.
Which brings us back to our final, and perhaps most critical, structural risk for you to consider. Given the deep financial interdependencies we've detailed here, where OpenAI is committed to over $1.4 trillion in infrastructure deals backed by billions in circular investments from its major partners, is the biggest risk to the entire sector simply the possibility of OpenAI's financial interconnectedness causing the largest systemic vulnerability.
It's not a question of technology, but a question of financial architecture failure.
Exactly, echoing the interconnectedness we saw in the 2008 financial crisis. If the single largest buyer in the market falters, the shockwaves will reach every single corner of this chip war ecosystem.
That is the risk we must track above all others.
Risk defined. Portfolio protected.